permanent magnet moving coil type ammeter, okay, PMMC ammeter, and moving iron type of ammeter connected in series in a resistive circuit. Okay, this is the resistive circuit. These are connected in series. Now, here we have an half wave rectifier. Okay, input to the half wave rectifier is AC, whereas output is DC. Now we have to find the reading of permanent magnet moving coil type instrument. Okay, now what is PMMC? It will read only DC values. So IDC is equal to, this is 2 into IM value he has given as 5 amperes. So average DC value for PMMC is 5 by 5. Okay, this will read 3.18 amperes. So option C is correct. So the properties of fast turn-off thyristors. Okay, he has given 3.0. First one is turn on with a pulse signal and turn off with a natural commutation. Okay, absolutely right. This is valid for SCR family. Okay, now they are for high switching frequencies up to 20 kilovolts. Fast turn-off thyristors cannot be applied for high switching frequencies. It is only having frequencies less than or equal to 5 kilohertz. So number 2 is wrong. Constant voltage drop is low. This is also the correct one, because example is the MOSFET we have. So both 1 and 3 are correct. So option B is the right answer.
In this problem, it is given that y is equals to root over x bar 10 plus root over x bar 10, so on up to infinite terms. Now we have to find the derivative of this, that is dy by dx. Now there are two ways of solving this problem. One is directly by formula. If y is a function which is root over f of x plus root over f of x plus so on up to infinity, then dy by dx is nothing but differentiation of the function f of x by 2y minus 1, which is dy dx of f of x, which is x bar 10 by 2y minus 1. If I differentiate x bar 10, it is 10 into x bar 9 by 2y minus 1, which is option A. And the other method is take this y root over x bar 10 plus root over x bar 10 plus so on up to infinity. Consider this entire term as y. Y is equals to root over x bar 10 plus y. Now squaring on both sides. After squaring, differentiate them, you will get the answer as A. In this problem, a function f of x comma y is given as 4xy minus x square minus y square. Now we have to check whether it has maximum, minimum, or neither maximum nor minimum. Now, in order to find that, first we need to find fxx, fyy, and fxy. Now, here fx is nothing but 4y minus 2x and fxx is nothing but minus 2. Similarly, fyy, if I differentiate the function twice with respect to y, it will be minus 2. And fx is always, already we know 4y minus 2x, and fxy, if I differentiate, it will be 4. Now, let us take the relation fxx into fyy minus fxy whole square. If this is less than 0, then the function will have saddle point. Now let us substitute the values. Minus 2 into minus 2 minus 4 square, which is always less than 0. So the function has saddle point. So the answer is option A.
The most commonly used type of arrestor is option C, thyroid. Thyroid is the most commonly used arrestor, lightning arrestor. Okay, lightning arrestor, we all know that. Okay, if there is any surge on lightning surge on transmission line, okay, there will be a capacitor here. This capacitor dielectric strength should be designed such that when lightning surge is of 10 kilovolt, this is acting as a short circuit. Okay, so the effect of the lightning surge is transmitted into the ground. Okay, the best suited for substation is thyroid lightning arrestor. So option C. Operating coil of the relay is, now in this relay we have operating coil is this one. Okay, we marked it current flowing through this one is I. Okay, now he has given the transformation ratio of this current transformer is some 200:1. Current flowing from this side is 1000 amperes, whereas this from this side is 2000 amperes. Okay, so 1000 by 200 is 5 amperes, whereas 2000 by 200 is 10 amperes. Okay, that means we have a direction of current flowing in this is 5 amperes, whereas with respect to this one is 10 amperes in the current transformer. So I is equal to summation of 5 plus 10, which is equal to 15 amperes. So option C is correct answer. Loaded distributor is fed at center as shown in figure. Now what is the maximum voltage drop it is having? Okay, let us take total line length is L. Okay, the line length up to center point C is L by 2, whereas from this one is L by 2. Okay, this is a uniform loading. Okay, uniform loading fed at center is equal to concentrated loading fed at both ends. Okay, now what is the maximum voltage drop for this one? It is IR by 8. So option D is the correct answer.